In 4.3, we're going to look at what it means for figures to be congruent. We've used that word congruent before to describe sides and angles, but today we're going to use it to describe shapes. So two polygons are considered congruent if and only if their corresponding angles and sides are congruent. Okay, so for example, we see three figures right here that are all exactly the same. They're just turned around, but they have the same size and the same shape. And all of their sides are congruent, and all of their angles are congruent. And so we would say that these two figures are congruent. These three triangles over here are not congruent because they are not all the same angles. They don't have all the same shapes, okay? So even though like these two look kind of the same, one is obviously bigger than the other. And so we would say that these are not congruent. Now, if two shapes are congruent, then we can say that all of their sides and all of their angles are congruent. So for instance, down here, we've got these two triangles, and we know that they are congruent triangles because all of their sides are the same and all of their angles are the same. So we're going to write what's called a congruence statement. So the important part of a congruent statement is that the order of your letters matters. So for example, if I wanted to say that these two triangles were congruent, then I'd write triangle, and I would start using the letters to describe it. So I might call this triangle KLJ. If I called this triangle KLJ, and I wanted to say that it was congruent to this other triangle, I couldn't just use whatever letters in whatever order. I couldn't say TRS, RST. I would have to make sure that the corresponding parts matched up. So for instance, I picked K to be first, and the angle that's the same as K is S. So I need to make sure that if I put K first here, that I put S first here. Similarly, if I put L second, then I need to make sure the angle that's congruent to L, which is R, is second over here. And if I put J last, then I need to make sure that I have the angle that's congruent to J, which is T, last over here. Okay, now this is one congruent statement that I could write. If I wanted to, I could write a different congruent statement. I could just put my letters in a different order. So let's say that instead of KLJ, I did, gosh, I keep doing that, I'm sorry. Let's say instead I did JKL. I went alphabetically, okay? If I went JKL, then I would need to say, if I start with J, the angle that's congruent to J is T, so I would have to have triangle T. The angle that's congruent to K is S, so I'd have to have S second. And the angle that's congruent to L is R. And so these are two different examples of a congruent statement that I could make about those triangles. Okay, there are lots of different ones that I could do. Those are just two that I happen to pick, okay? But there are actually several different combinations that we could use. Roman numeral 2 says, use the congruent statement to list all of the congruent angles and the congruent sides. So we don't even have a picture here, right? But what we know is that the parts that correspond must be congruent. So if A is first, it must be the same as F. So I'm going to say that angle A is congruent to angle F. If B is second, then angle B must be congruent to angle E. And if C is third, angle C must be congruent to angle D. So that's the congruent statements for all the angles. Let's do the same thing with the sides. So let's see if we've got three different sides, AB, BC, and AC. So if we said that AB, if we wanted to know which one it was congruent to, if A and B are the first two letters, then it'd have to be congruent to the first two letters over here, F and E. AB is congruent to FE. The second side of my triangle would be AC. And AC would be congruent to if A and C are the first letter and the third letter, then I need to use the first letter and the third letter here, FD. And then for my last one, the two letters, the sides I haven't used yet would be B and C. So BC would be congruent to ED. It's really important that all the parts match up. So let's look down here at this bottom part where we have two congruent triangles, and we want to find all those parts that would be congruent. So let's see what we got. We've got AB. So let's see. AB is, oh no, what'd I do? Sorry, guys. My computer has a very sensitive touch screen, so sometimes it appears that I lose what I'm trying to do. So I want to rotate that back. Oh gosh, I'm sorry. There we go. It's kind of weird, but it'll work. As long as I don't mess it up anymore. Okay, so let me see if I can get out of that. So I would like to identify those corresponding parts. Here's what I was trying to do. I was trying to label the sides. So here's AB. If I want to know the part that's AB, I need to pick the part of the triangle that has one tick mark on it. The one tick mark would be GH. I could put GH or I could put HG, but since they have the AB first, and the A is on the angle that has two little marks right here, I'm going to write H first. And I'm going to call this HG. So let's pick a different side. We've got HI now. So I'm going to highlight HI. That's this side that has 3 on it. And so obviously HI is going to be this other side that has 3 tick marks on it. We're going from H to I. So H has the 2 lines here. So I'm going to use A to C to show that those are congruent. And then last, we've got CB. So CB is obviously going to be this side. And the angles that are the sides that are congruent there would be I and G. So C started with 1 line, so I'm going to start at I. And I'm going to go to G. And then much easier to do would be the angles. The angles to me are the easiest part. So if I'm looking at this and I've got angle A. Angle A is this one right here with 2 marks. And so angle A is going to be congruent to angle H. Angle C here has got 1 line, and so that's congruent to angle I. And angle B, the one left over that doesn't have any marks on it, is going to be congruent to the one that doesn't have any marks over here, which is angle G. In number 2, it says complete the congruence, the triangle congruent statement. So these are 3 different ways that we could write congruent statements. So we're going to kind of investigate what we got going on here with these triangles. If we started B, A, C here, then we would need to start with the angle that corresponds to B, which we know is G. So this would be triangle G. And then the A here corresponds with H here because that has 2 lines. And the C with 1 tick mark corresponds to the I. So this would be congruent to GHI. Let's do something similar for HIG. Oops, sorry, wrong button. So HIG, let's see. H corresponds to A. So this would be triangle A. The I corresponds, oh, I'm sorry, I have that wrong. Sorry. The H corresponds, oh, no, I don't. Sorry. Losing it over here. The I, which has 1 line on it, would correspond to C over here. And then that leaves the G, this guy, to correspond with B. So the only thing you could have there is triangle ACB. And then in a similar way, if we get these to match up, the C, which I have in green, corresponds with I. The B, which I have in blue, corresponds with G. And the A, which I have in red, corresponds with H. So those are my triangle congruence statements there. So the third angle theorem states that if you have 2 angles that are congruent to 2 other angles in another triangle, then the third must also be congruent. It's kind of common sense. But if you have 2 pieces that match up, then the third piece must also match up. So the leftover parts will also be congruent. So what will this look like in real life? Let me give you some examples. We're going to turn the page over here and have a look at what kinds of things you might see on your homework for today. So let's say that we're working on the first problem, which is listed as number 3 for some reason. I guess we had number 2 on the other page. So if RQPS is congruent to FEDG, then PR would have to be congruent to. So here's the question. If PR would have to be congruent to, and we want to find the parts that would match up. So P is the third letter, which means it would match up with D, and R is the first letter. So we would say that PR is congruent to DF, segment DF. In a similar way, over here, if we had TRY congruent to GUD, then angle D, that's this guy, would have to match up to the third point in the other one, which is angle, I don't know why it won't let me do that, angle Y. For some reason I can't write right there. And then the ones that you're going to see the most of are the ones that look kind of algebraic. So like what we have here in number 5. So we've got 2 congruent triangles. Let's find all those parts that match up. So it looks like R S, and T we have, and it says that R is congruent to L. So don't just go by how they look. You need to actually make sure that they match up. R matches up with L. S matches up with M. And T matches up with N. So those are the pieces that are congruent. So now we need to find some congruent sides and congruent angles. So I'm going to start with the sides. Let's see. I know that RS here is 20. So what would RS be congruent to? Well, R and S are the first two letters. So it'd have to be congruent to LM. So I could say that 20 must equal y plus 14, which means that y is going to equal 6. Now we know that if y equals 6 and side MN here equals 2y, that side MN must be 12, which was one of the things that we were looking for, MN. And what about X? So X appears to be dealing with the angle. So we've got ourselves over here, angle T, which we know is 88. And the angle that matches up with T is going to be angle N, because they're both in the last position. So I'm going to say that angle T, 88, is congruent to angle N, which is 8 minus 2x. So I'm going to solve that equation. 80 equals negative 2x. And if I divide, I'll get negative 40 for my x. That's funny. Oh, no, that looks good. Never mind. Sorry. I thought I had a mistake, but I'm good. Okay, let's have a look at number 6. We've got DEFG congruent to SPQR. So let's do some labeling. D matches up with S. E matches up with P. F matches up with Q. And R and G would match up. So let's see what kind of information we're looking for. One of the first things we need to find is this side right here, QR, is 2x minus 4. So what side would match up with QR? Well, Q and R are the last two letters, so they would match up with F and G. So I would say that those two sides are equal. 12 equals 2x minus 4. Which means that x would equal 8. And the next thing we need to find is what angles match up. So we know this guy over here is 6y plus x. And we want to figure out what angle matches up with Q. Well, Q is third, and so that would match up with F over here, right? Angle Q is congruent to angle F. So we know that those two have to be equal. 68 must equal 6y plus x. But if you remember correctly, x is 8, right? So that means 68 equals 6y plus 8. So now I just need to solve for y like we have been doing. 60 equals 6y. And I would get y equals 10. All right, so moving right along. 7 and 8 are very similar, except that what's kind of annoying about 7, 8 is that they're not giving us pictures. And so if you don't have a picture, I think it's kind of hard. You might be able to sort of envision it if you want. But we need to keep all those corresponding pieces in sorry. We need to keep all those corresponding pieces in mind. So if you want, you can draw two triangles, QRD. I have no idea what they look like. I'm just making this up. QRD and PLK. I'm just making sure that if I have QRD, that I make PLK. And then I know that my corresponding angles would be here, because that's what they told me in my picture, or my congruence statement right here. So we got to find all those pieces that would match up. We've got angle Q over here. Q looks like he matches up with P, right? And then we've got R that matches up with L, and D that matches up with K. So let's see what information they have given us and how we can use that. We know that angle Q is 97, which means that angle P is also 97. We know that angle K is 37, which means that angle D is also 37. And we know that angle R is 4x plus 14. So the big question is, how can we use that to find x? And there are several different ways that we could mess around with that. But basically, the thing that we know is that all of these angles have to add up to 180 degrees, right? And so we know that, for instance, these three over here add up to 180. 4x plus 14 plus 97 plus 37 has to equal 180. And so let's see, I've got 4x plus, and I'm going to combine all these numbers together. And I think I'm going to end up with 148. You can check me on that if you want. My next step is going to be to subtract 148. 4x equals 32, which means that x equals 8. Number 8 is really similar to that, except instead of only having 3 letters, we've got 4, which means that instead of having a 3-sided figure, we have a 4-sided figure. I have no idea what it looks like. It might be a square, it might be a rectangle, it might be a parallelogram, it might be some crazy shape that doesn't have a name that we know about. I just know that those two things should be the same. If I've got A, B, C, and D, then over here I need to have X match up with A, Y match up with B, Z match up with C, and W match up with D. Okay? And I just totally made up that shape. Who knows what it really looks like? But we know that BC equals 38, XY equals 28, and YZ equals 5x plus 8. Another color for that. YZ is 5x plus 8. So what pieces are going to match up? Well, it looks like BC is going to match up with YZ. And so I'm going to set BC equal to YZ. X would equal 6. Now you might be asking yourself, Mrs. T, how come you didn't use the 28? And the answer is we didn't need it on this problem. So we were kind of lucky. We had some extra information. I know you guys are not a big fan of when you have extra stuff you don't need, but that's what happened here. Okay? All right. My kids are going crazy out there. Can you guys hear them? So if we want to prove that triangles are congruent, then we need to look and see if the pieces of the triangles are also congruent. This is a little bit sneaky, but is good stuff to think about. So do we know that these two triangles are congruent? Triangle ABC and triangle ADC. So what's kind of important here is that you notice that these two triangles share a side right here. And if two triangles share a side, then that side has to be the same because of the reflexive property. Remember the reflexive property? It says that if you have AC on one triangle, that's going to be congruent on the other triangle. Do we know that any other pieces are congruent here? Well, let's look. We know that this angle is congruent to this angle, and that this guy is congruent to this one. So the question is, are the remaining angles going to be congruent? And the answer is yes, they are. Angle B has got to be congruent to angle D. And the reason is that third angle theorem. Remember back here when we talked about the third angle theorem? If two angles are congruent, then the third angle must be congruent. So if we have two pairs of congruent angles, the third angles must be congruent as well. So I would say angle B is congruent to angle D, and the reason is that third angle theorem. So let's look at these last two pieces. We've got three congruent sides here. We've got, let's see, this guy's congruent over here, and this guy is congruent over here, and this guy is congruent over here. So the question is, what other pieces of information do we know? And they want us to be able to say why. So the first one is PTS congruent to QTR? Is PTS congruent to QTR? Well, I am sure hoping that you're looking at those two angles and thinking they have to be congruent. And the reason they have to be congruent is that they are vertical angles. And we know that vertical angles are always congruent. That one's not super sneaky, but the next one is a little bit sneakier. So let's look. P and R. What does this little symbol right here mean? Well, that means that these two lines right here are parallel lines. And what is the significance of parallel lines? If you remember, if we have parallel lines that are cut by a transversal, for example, this guy, okay? If parallel lines are cut by a transversal, then we happen to know that the angle here and the angle here, which I'm going to label as angle P and angle R, those two angles have to be congruent. Do you remember why? If we have two parallel lines and those guys are on opposite sides of the transversal, we would say that they are alternate interior angles. And so they must be congruent. In kind of a similar way, we have two parallel lines cut by a different transversal. So we've got those same two parallel lines, but this time we're going to talk about them being cut by this guy, SQ. So SQ moves like this. So this is my transversal, and my red lines are parallel. And we know now that this angle here, which is angle S, must be congruent to angle Q up here. These two guys must be congruent. And the reason they must be congruent is they are also alternate interior angles.